So, what is the universe really made of? And I'm not talking about atoms or quarks. I mean the actual fabric of space-time itself. Is it this perfectly smooth, continuous sheet? Or is it more like a digital photo made up of incredibly tiny, fundamental pixels? It's a mind-blowing question, and that's what we're going to dig into today.
Okay, let's just start with a little thought experiment. Imagine you've got a microscope so powerful you can just keep zooming in. You zoom in on your hand, past the skin, past the cells, way down past the molecules and the atoms. If you could just keep going deeper and deeper, what would you eventually find at the very bottom of it all?
Would you find this continuous, unbroken fabric of reality? Or would it be just like a digital image, where if you zoom in far enough, you finally see the individual pixels? This is honestly one of the biggest and most fascinating debates happening in physics right now.
Now, this whole idea that the universe is pixelated, it might sound a little like science fiction, right? But believe it or not, some really prominent theories in modern physics are proposing exactly that.
This idea is really at the heart of theories like loop quantum gravity. It's an attempt to bring Einstein's theory of relativity and quantum mechanics together. And it suggests that space-time can't be divided up forever. Instead, reality itself has a fundamental resolution, a smallest possible unit. You just can't zoom in any further than that.
Okay, but here's the thing. It's a pretty radical idea, and before we can even begin to think it's a true description of our universe, the theory has to clear 5, let's call them huge hurdles. 5 critical questions that, so far, nobody has an answer for.
All right, so let's get into it. We're going to walk through each of these 5 major challenges one by one that any theory about a pixelated universe has to solve.
First up, and this is a big one, if the fabric of reality itself is made of pixels, then everything in reality, you, me, the stars, everything, must also be built from them. So how do you actually construct the building blocks of matter?
So in physics, the fundamental particles that make up all the matter we see, electrons, quarks, that kind of stuff, they're called fermions. And they have this really unique, kind of weird quantum property called spin. For fermions, this spin comes in half-integer units, and that's a crucial detail that makes them, well, them.
And here's the punchline, the big problem. The folks who support these pixelated spacetime theories haven't yet been able to show how you can arrange their fundamental pixels to create something that actually acts like a fermion. And if you can't build fermions, you can't build matter. Big problem, right?
Let's move on to the next hurdle. If these pixels are the most fundamental thing there is, the absolute bottom layer of reality, then they must have their own set of rules. They've got to have properties. But what are they?
I mean, what is a single pixel of spacetime? What are its properties? What rules does it follow? Right now, those are all completely unanswered questions, and you can't really build a solid theory on a foundation that's a total mystery.
Okay, this next question sounds super simple on the surface, but oh boy, it reveals a really tricky logical trap for this entire idea.
Just think about it for a second. If the pixels are made of something even smaller, then, well, they're not the fundamental unit after all, are they? And you're just back to asking what that smaller thing is made of. It's that classic turtles all the way down problem. But if they aren't made of anything, then what even are they? See the problem? The theory just doesn't have a good answer.
All right, hurdle number 4. If reality is a grid of these discrete pixels, that means there have to be gaps, right? Little spaces between the pixels. So what's in those gaps?
So what's going on in the gaps between these pixels? Is it just nothing? Nothingness? If that's the case, how does anything, a particle, a wave of light, travel from one pixel to the next? How do things move and interact across these little voids of nothing? It's another fundamental problem for the theory.
And that brings us to our 5th and final hurdle. For all these pixels to create the complex, dynamic universe we see around us, they can't just be a bunch of isolated dots. They have to work together. They got to communicate somehow.
So what's the specific mechanism for this interaction? How do countless trillions of these individual pixels combine and coordinate their behavior to form something as vast and structured as a galaxy? This is another one of those core, unanswered questions right at the heart of the theory.
So, with these 5 huge hurdles still standing, where does that leave us? Well, the fact that these really fundamental questions are still on the table has led a lot of physicists to start considering an alternative view of what reality is.
As our source material concludes, this consistent inability to solve these basic issues makes many people think that the foundational idea itself, that the universe is made of pixels, is probably flawed.
And this illustrates the leading alternative beautifully, that space-time isn't some rigid grid of pixels, but instead it's a smooth, continuous, and elastic fabric, a dynamic medium that can bend and stretch and ripple, which is exactly what Einstein's theory of general relativity describes.
So, is the idea of a pixelated universe totally dead? Well, not necessarily. But these 5 hurdles really drive home just how much we still don't know about the fundamental nature of reality. The search for the ultimate ingredient of our cosmos is still going on, and it's one of the greatest scientific adventures of our time. So I'll leave you with this. What do you think reality is made of?